And today we're going to learn about waves. This is a wave. This is the median point of the wave. One wavelength is from one point to exactly the same point. So that would be one wavelength. Right there to there. The top of the wavelengths, the peaks, are called the crests. And the bottom peaks are called the troughs. Spelled T-R-O-U-G-H, but it's pronounced trough. From crest to the median point is the amplitude, but that could also be measured as from the median point to the bottom of the trough. It's also the amplitude. A period is one oscillation. So in this case, that would just be like that wavelength. So it's the time it takes that one oscillating wavelength to happen, that one oscillation. So the frequency of a wave is equal to 1 over the period. It's measured in hertz, so in other words, the frequency is 1 cycle per second. And now Natalie's going to show us the equations. Natalie? So the frequency of a wave is equal to 1 over the period. It's measured in hertz, so in other words, the frequency is 1 cycle per second. And now Natalie's going to show us the equations. Natalie?
Frequency is how many cycles occur in 1 second. So this equation is written as 1 over t. Frequency is measured in hertz. Hertz is cycles over seconds, which is how you get 1 over t. Now, t is period, which is the inverse, so it's 1 over the frequency. T is measured in seconds, just like time. To find the velocity of a wave, you multiply the frequency, which is f, times the wavelength. Now lambda is the sign for wavelength. So velocity is frequency, which is cycles per second, times wavelength, which is technically meters per cycle. So the cycles cancel out, and that's how you get velocity equals meters per second.
Just kidding. So now we're going to do a real life problem. Red light has a frequency of 4.0 times 10 to the 14th power hertz. The wavelength of red light ranges anywhere between 650 to 750 nanometers. So for this problem, we're just going to use the in-between point, which is about 700 nanometers. So the wavelength is equal to 700 nanometers. In order to find the velocity of the wave of red light, we have to first convert 700 nanometers into meters. So the conversion factor for this 1 meter is about 10 to the 9th nanometers. Okay, so when you divide it out, you get a wavelength of about 7.0 times 10 to the negative 7th meters. So in order to find velocity, we're going to use the equation which Natalie showed us before, which is velocity is equal to frequency times the wavelength. So this is going to be equal to 4.0 times 10 to the 14th hertz times 7.0 times 10 to the negative 7 meters. When you add all these out, get about 2.8 times 10 to the 8th meters per second.